Okay, today's a pretty easy day. The second hour had like 20 minutes to work on the homework. So, pretty easy notes today. We're just going to kind of add one thing to what we talked about yesterday as far as writing the equation of a line. Today we are going to talk about parallel and perpendicular lines. So, you did this last year, so this isn't new information, but I do understand that we tend to forget things at times. So we'll go over it again. So what we're doing today is we're writing the equation of a line, but in particular we're going to write the equation of parallel lines and of perpendicular lines. So let's start with parallel lines. When it comes to, we've been dealing with parallel lines a lot, but not in the coordinate plane, not in the coordinate grid. So when we're graphing parallel lines, what's important about parallel lines that's helpful? They don't intersect. That is true. What else? They're never ending. Yes. They have the same slope. That's going to be really helpful today. You guys want to hear a joke about parallel lines?
Sure.
Really funny. Parallel lines have so much in common. Slope. It's a shame they'll never meet. Even till second hour, it's even funnier now. It's so funny. Okay, so parallel lines have the same slope. So if you look at these lines, you can see that they're parallel. If I look at their slopes, pick a point, pick another point. We rise 3, run 1. So 3 over 1. That line has a slope of 3. The other line, if you pick 2 points on it, rise 3, run 1. 3 over 1 also has a slope of 3. So, like Elijah said, parallel lines have the same slope. So what we're doing today is we're going to have something that looks like this, right? The equation of a line that's parallel to y equals 1/3 x minus 2. Okay, so you can kind of picture that line in your head. But passes through the point -3, 6. Okay, so most of what we do is the same as yesterday. We're going to use point slope form. Y minus y1 equals m times x minus x1. Just like yesterday, to use point slope form, we're going to have to plug in y1, m, and x1. Just like yesterday, the x1, y1 is a point the line passes through. They give me that. This is a line, or this is a point the line passes through. That's your x1, y1. Now the slope is going to come from this equation. Because I want a line parallel to this line, which means my line needs to have the same slope as this line. Well, what's the slope of this line? 1/3. So the slope of my line, 1/3. And then you're going to plug in the other numbers the same way we did yesterday. We're going to do y minus, my y1 is 6, equals, we said the slope is going to be 1/3. And then be careful with the signs. X minus a -3 is going to turn into a +3. Now, like yesterday, I don't care what the directions say. I don't care what the back of the book says, Slater Photomath. Any of that says, I want your answers in the slope-intercept form. So just like yesterday, we're going to want to get rid of the parentheses. So we distribute y minus 6 equals 1/3 x plus 1. And then to get rid of the minus 6, we would add 6 to both sides. Y equals 1/3 x plus 7. So we'd have this original line would cross at -2. This line would cross at 7. But they're both going to rise 1, run 3. They would be parallel. Okay? Now, we also have perpendicular lines. Just like when you're not in the coordinate plane, perpendicular lines intersect at a right angle. But there's something special about perpendicular lines. Anybody remember from last year? Their slopes are opposite reciprocals. So watch this. If I find the slope of this line, to get from that point to that point, we'd rise 2, run 1, 2 over 1. That line has a slope of 2. And if I go to the other line and pick 2 points on this line, I rise -1. I go down. So down 1, right 2. So -1 over 2. That slope is a -1/2. perpendicular lines, their slopes, they're going to be opposites, meaning one's going to be positive, one's going to be negative. Okay? And then they're going to be reciprocals. So 1/2, you flip it over, you get 2. So the slopes, flip the sign, and flip the fraction. The rest of it's the same. We're still using point slope form. Y minus y1 equals m times x minus x1. We still need a y1, an m, and an x1. They give me the point to plug in, but I have to take my slope from this line. My line needs to be perpendicular to this line. So if the slope of this line is -4, my slope needs to be the opposite reciprocal. So you flip the sign and you flip the fraction. So what would the slope of the new line be? A positive. You flip the sign, 1/4. Flip it over to 1/4. So we would do y plus 1 minus a -1 return to a plus 1 equals 1/4 times x minus 8. We distribute the 1/4, so y plus 1 equals 1/4 x. 1/4 times -8 would be a -2. And subtract 1 from both sides. We get y equals 1/4 x minus 3. There we go. That's all we're doing today. Parallel perpendicular lines. All right. Let's get this glued in. This will be the last section in chapter 3. Yes. No, no, speaking too soon. Yes, last section in chapter 3. So we should have all of our chapter 3 notes. This is going to go on page 45, section 3-8. Parallel and perpendicular lines. So the first couple examples, we're going to write the equation of a line parallel to the given line that contains the point that's given. So number 1. So my line is y equals -3x plus 5, and point C is -1, 8. So what I want to do is I want to write the equation of a line that's parallel to this line, but it's going to pass through this point. So we're going to use point slope form. Y minus y1 equals m times x minus x1. Just letting you know that on your test on Tuesday, I will give that to you. It's not super hard to memorize, but if you're having a hard time with it, I would just recommend writing it down and writing it down and writing it down again. It's the easiest way to memorize it. Okay? So we need a y1, an m, and an x1. So my y1, x1 comes from the point, but the slope needs to come from my other equation that I'm given. My slope needs to be the same as this slope. So what's this slope? -3. So my slope, -3. The rest of it's the same as what we did yesterday. We're going to do y minus. My y coordinate is 8 equals -3 times x minus -1 would turn into a +1. And then we want to make sure we write it in slope-intercept form. So y minus 8 equals -3x minus 3. And then to get rid of the -8, we will add 8 to both sides. So y equals -3x plus 5. I would say the two biggest mistakes that I see with point slope form is people switch the x's and the y's, okay, and then mess up on the signs. So just be really careful on those two things. Yes. Oh. It would be, I didn't think it was going to matter. My original problem was -5, and I was like, it won't matter. It didn't matter. So, here we go. Okay, number 2. Y equals -3/4 x minus 1 and passes through the point -8, 3. Alright, so we have our point slope form. Y minus y1 equals m times x minus x1. We have our x1, y1 from our point, but I need my slope. And we're going to get our slope from this line because it's going to be the same. So what's the slope of the new line going to be? Yeah, -3/4. The same as the slope of that line. Everything else is the same. Y minus 3 equals -3/4 times x plus 8. Remember, do minus a -8. Distribute the -3/4, so we have y minus 3 equals -3/4 x. -3/4 times 8 gives me -6. And then add the 3. So we should get y equals -3/4 x minus 3. Questions on writing parallel lines? All right, so let's move on to perpendicular lines. Almost everything is the same. The only thing that's different, instead of taking the same slope, we're going to take a slope that's the opposite reciprocal. So you're going to flip the sign, and you're going to flip the fraction. Number 3, y equals 1/5 x plus 2. And it's going to pass through point P that is at 15, -4. So on all of these, we're still using point slope form. Y minus y1 equals m times x minus x1. We're going to plug in our y1, our m, and our x1. We've got our x1, y1. That's the point that the line is going to go through. But I need my slope. Now, the slope of this line is 1/5. The slope of a line perpendicular to this line needs to be the opposite reciprocal. So we flip the sign and flip the fraction. So what slope am I going to use? -5. Very good. Negative, flip the sign, and 5. 5/1, we could just write that as 5. So we'll do y minus a -4, return to a y plus 4, equals -5 times x minus 15, and then convert it to slope-intercept form. Y plus 4 equals -5x plus 75. Subtract 4 from both sides. We have y equals -5x plus 71. Okay, for number 4, let's set it up together. We'll get to this point together, and then I'll have you guys finish it out, put it into slope-intercept form on your own. So number 4, y equals -3x minus 4. It is going to pass through point P at -3, 7. Actually, let's do this. Why don't you guys go ahead, plug the numbers into point slope form, and then let's stop and check, and then I'll have you finish it out. So plug your numbers into point slope form. We'll stop and check, and then I'll have you finish it out. Alright, so who can tell me what this would be in point slope form? Brianna. Very good. Y minus 7 equals, the opposite reciprocal of -3 would be a positive 1/3 equals x minus a -3 would be +3. Okay, so now I want you guys to go ahead and finish it out. Put it into slope-intercept form. So distribute, and then move that other number over. All right, so when you distribute the 1/3, we should have y minus 7 equals 1/3 x plus 1. Add the 7 to both sides. We have y equals 1/3 x plus 8. Questions on perpendicular? perpendicular lines. Okay, last thing, instead of writing the equation of a line, let's talk about how we can look at two lines and decide if they're parallel. So, number 5, the two lines we're going to look at are 2y equals 15 plus 4x, and then 6y minus 30 equals 12x. So if we wanted to decide if these two lines are parallel, what do I need to know about these two lines? If I want to know if these two lines are parallel, what would I need to know about these two lines? Yeah? I need to know their slopes. Can you tell me what their slopes are as they're written? Shouldn't be able to, because to tell the slope it has to be in y equals. So we're going to have to put them into slope-intercept form. So that first one will divide by 2. We get y equals 15 over 2 would give you 7.5. 4x over 2 would give you 2x. Now the second one, to put it into y equals, what's the first thing I'd have to do? If I'm solving for y, I've got the 6 and the minus 30. Which of these would I have to get rid of first? The 30. Yeah, I have to add 30 both sides. So we have 6y equals 12x plus 30, and then divide by 6. So we have y equals 2x plus 5. So are these lines parallel? Yes. Now I know this one isn't written in mx plus b, it's kind of written in b plus mx. But yes, their slopes are both 2. So we'll say yes, slopes are both equal to 2. Let's do one more of those. So this one says 10y plus 130 equals 50x. And the second one says negative 5y equals 2x plus 11. Now, same idea here. You need to put them into y equals so we can find out their slopes. So for that first equation, what's my first step in getting that into y equals? Subtract the 130. So we have 10y equals 50x minus 130, and then we'll divide by 10, so we have y equals 5x minus 13. Now for the second equation, to solve that equation for y, what would I do? Divide by a negative 5, so you have y equals negative 2/5 x minus 11 over 5. Are these lines parallel? No, they both have 5. That doesn't mean anything? Yeah, no, it doesn't mean anything. Parallel, different slopes.